This lecture is about error handling in Python, and particularly try statement. At the end, some small part will be devoted to modules. So, there are many cases in programming languages in which your code has errors. In that case, compiler throws some message and your code stops from executing. So it would be useful to use error handling technique in that programming language. In Python, you can try statement. So the syntax of which is you write try, then colon, and from the next line after indent, you put your code to be executed. If there is an error in your code to be executed, next line handles the error. So you write from the next line except and the error name. For example, index error and etc. After colon from the next line, you put the code that would be executed in case there are errors in your try block. There are also two optional statements, else statements and finally statements. Else statement will be executed in case there are no errors in your try block, and finally statement will be executed in any case. Finally statement is especially useful when you open or close database connections. So if you do not handle that, your database would not be closed. So you put database close code in the finally and it would be executed in any case, in case there are errors and in case there are no errors. So let's move on to IDE to see in action how a try statement is used. So let's create a mylist list with members from 1 to 5. And also let's define list member function with an index argument which will return mylist members by index. And here let's use this function with inappropriate argument. For example, let's use out of range index. Compiler will return a message that the index is out of range. Let's use string as an argument. Compiler will complain that you should use only integers and your program will stop from executing. So let's put this code inside try statement. We create inside try statement index variable with a value of 5 and recall that it's out of range. And we write the code to call the function, list member function, with an argument index. And remember that we got index error when we used out of range index. So we should handle this error. So in our case, our program will print the message that index out of range and please try smaller value. We have had also another error, which was type error. So we should also handle this error. So you notice that we can use multiple except blocks. So in case of type error, our program will print please use only integers as index. We could also have another type of errors for which we write another except block with no error types specified. In this case, our program will print that there was some other error in the program. We also specify optional else and finally blocks. So in case of else block, our program will print that this statement will print only if there are no errors in the code. And recall that the code inside else block will print only if the code inside our try block has no errors. In the finally optional block, we put the code to print that this statement will always print. So let's execute the code to see how our program handles errors. Let's comment out other statements that will be printed. So here we have index out of range, please try smaller value. And recall that also the code inside finally block was printed. So let's specify the index as string. In our case, the code will say please use only integers as index, and also the statement inside finally block should also print. In Python, you could also manually erase errors. So, for example, let's make our program to erase key error when the index value is 5. In this case, we write erase key error. And remember that our program handled also other than type and index errors. So here, when we execute the statement, it will print that there was some other error in the program, and also it has printed the statement or the code inside finally block. Now let's continue to modules. Imagine a situation in which you have written in the past several functions and you want to use all those functions in your current script. One possible way is to copy all the code that describes or defines all those functions into your current script and reuse them again. But Python offers you a very comfortable way to reuse your code that was written in the past. So in this case, you can put all your function definitions in a separate py file, and you can import which is called module, and you can import your module into your current script in 3 ways that you see on your screen. The first way is to import my module and the name for the my module to be used in your script. The next one is from my module import everything, which can be done by asterisk. And the third way is from my module import specific function. All these 3 ways work, but there are details that I would tell you when we used all these statements in the IDE. To use modules, we need to create a separate file folder for the modules. Here our module is called my module. And we define here 2 functions. Multiply function, which multiplies its argument and prints the result, and add function, which just adds its argument and prints the result. So this one is the mymodule.py file. Our main script file is called myscript.py, which we'll see next. So this one is myscript.py file. Here we import our my module and specify the name, short name that would be used in our script. That name is mm. We call the functions inside module by specifying the module name dot the function name. So here dot multiply and with arguments 5 and 6 returned 30 value. Add with arguments 51 and 60 will return 115 value. So there is another way to import our module into main script. We can specify from my module import asterisk, which means everything. And in that case, we do not need to specify the module short name, as it imports all the function names into the namespace in our current script. And you see that calling those functions work here.